We ask a lot of these bearings. They're already subject to hundreds of pounds of preload, which allow them to keep your spindle from moving around as you apply hundreds of pounds of side loading while it's doing tens of thousands of RPM. That's no easy task. And these bearings are grease packed. There's grease that's sealed into the construction of the bearing, which lubricate these bearings for the life of the units. In the world of hobby CNC equipment, there are only a couple of topics that I am qualified to speak to, and spindle bearing construction and care is one of them. So let me help a lot of you save yourself from some expensive early maintenance and replacements. Let your spindle warm up before you cut. Here's why. Now, most of us are familiar with the construction of a basic rolling element bearing. You have an inner race, an outer race, and the rolling elements.
Duh.
Here we have a bearing ball in an inner or outer race. It's a reasonable assumption on the part of the layperson that the bearing simply comes into mechanical contact, that the ball bearing and either the inner or outer race are in direct metal-to-metal contact as it's rolling around. But reality is much weirder and more interesting than that. Now, as hard as they look, the materials that your bearing ball and your races are constructed of actually have elastic properties. They'll stretch like a rubber band. And when the bearing is properly preloaded, that forms not a point of contact, but a surface that we call the contact patch. Now, the contact dynamics of this interface is very complicated, but suffice it to say that if this truly were metal-to-metal contact, these surfaces would not last very long. Critical to the function and longevity of almost all modern rolling element bearings is a very thin film of fluid between the rolling elements and the races. In the region of the contact patch, this fluid film is squeezed and sheared to a tremendous degree, but in a manner that prevents metal-on-metal wear of these two elements. If it ain't the prettiest, at least it's repeatable. Now, before you flame me for talking nonsense, imagine that this guy's butt is a bearing ball, and that this lake is that film of lubricant. Clearly very effective. I literally searched butt skiing to find this video. This is grease. It's an oil in a suspension of a material that increases its viscosity so that it stays in one spot and doesn't run everywhere. This grease happens to be cold, and its viscosity is relatively high. If you roll a ball bearing through it, it gets pushed out of the way and it stays there. The problem, of course, is that the next time this bearing rolls through that same location, there's no oil in the region where that contact patch forms. That leads to metal-on-metal contact and premature wear of those surfaces. This is what's happening if you start cutting when it's cold. If you let your spindle warm up, notice what happens. The viscosity of the grease decreases, and it's much more able to return to the region where it needs to deposit that oil the most.